Welcome to a new test and teardown video. This time it's a Danish brand called Tage Juul Electronic. And they made all sorts of test equipment. They're mostly known for power supplies, and I got two power supplies here. The A50 and the A51. And the fun thing is, at the first little look at them, you don't really see the difference. But if you look a little bit more careful, you would see voltage, current, voltage. Really? Is this the only difference? And is this some sort of an argument or a statement? Does it really matter? I think that is so funny, but that is all I see on the outside, really. We don't have the schematic of this power supply. If you know where to get it, if you have it, if you have an uncle or whatever, I really want the schematic, so please find it and send it, or tell me where to get it, okay? Let's look at the back. They are, of course, from the start 60s or something like that, right? They are transistor based. And we got this really old AC connector here, and this is really funny. So they made a round hole and the diameter actually fits. See? It kind of works, but it looks really weird. So this is the A51, serial number 580. Yes, so let's look at the other one. Yabba dabba doo. This one is the A50 and says 349. And see, here there's a different plate where it says the full name and electronic Herlev. So that's the city and the country. They smell really weird. So I feel like I need to sneeze all the time. I better open and make a deep visual inspect before I power anything up here, because I don't want to create a new fire hazard or something like that.
Thank you so much.
Yeah. So now we're inside those fantastic power supplies, and they were covered in a thick slimy, stinky dust cloud, and that is what smells so bad. So with a paintbrush and a lot of compressed air, I cleaned them nice and fine. So now we can even see the color of the different components and all that. Meanwhile, I was able to find the schematic of the A50 version, not the A51. And I will show the difference in a little second, and then we'll take away the new A51 model here. So this one is using, as you can see here, a little bit more modern type of transistors, and the two linear regulators, the power transistors right here, they are 2N3055s, and all transistors here, they are NPN transistors. So that is actually the only difference. This is really weird. So we have two models and they look exactly the same, except this voltage and current, they have changed the position, but the entire construction is exactly the same. Look here, side by side. So this is the A50 model, and this one is from about 1965. At least the schematic is dated 65, or I think this is the drawing number, but I think this is actually the year code. Look at the transistors here. Those are AC128s, PNP transistors. And look at the circuit board. It's almost the same, but they just flipped everything upside down from NPN transistors to PNP transistors just a few years later, where NPN transistors just became more and more popular. I find that a little bit interesting. So let's try and test this power supply. And because references and drive voltages and all that is done using separate voltages, obviously you would expect this one to be a little bit unstable during power on and power off. So I just crank down output voltage to 0, and then I get about 0 voltage output. So what happens? Yeah, exactly. And then you get some output, only 2.7, so hardly enough to destroy something or to be any kind of hazard. So let's try and crank up the voltage. I put the voltmeter here in 32 volt range. Let's try and... Ooh, can you see what's going on here? This is the output voltage. Oops. And here we got some problems. And it goes to full voltage, but if we continue, so there is a, and then it continues. Oh, I had the idea we just, so okay, so up here it's good. And in this area here, we got a lot of disconnects. I can actually also feel there's something wrong with this one. Okay, so let's try and play with the current. Is this one? No, it's not going to absolute 0, but I didn't expect that for this transistor regulator stuff. So I think my first idea is to go and see if I can fix this potentiometer, maybe just desolder the wires and put in a separate potentiometer and see if it's nice and stable with that instead of this is useless. Over here I connected an external potentiometer to the power supply and see if I adjust the voltage here. We see a lot of good stuff here in voltmeter mode, and it is of course nice and stable and everything fine. What I did before is I was playing with the current, so now we can try and play with the current potentiometer here, and that is nice and stable. So all I need to do is investigate what can I do for this one. So here's the old potentiometer. I mean, if this is from about 1965, maybe its life is over, and it really feels weird as well. So let's open and see how bad it looks inside. Look at this. Now we know why it's not working. So here we got some lubrication. Look at that. And here, see, there's a big splat right there. And when the slider's supposed to go over here, see, disconnect. Ugh. You can really feel it. What if I try and clean this? Maybe it can be fixed just for the fun of it. So I think that was actually a little bit funny. Now it goes super nice and smooth. I like to add a little drop of lubrication, and then let's try and assemble it again. It's actually real easy to open these and to service them. And there's this little notch you see there. This made with this, and then everything is fine. So you can bend these back and then it's okay. So now the good old potentiometer is in and it's cleaned. And look at that. We got a real nice, smooth voltage adjustment. So let's try something funny. Let's try and put this 20 volts. I don't know. This is as accurate as I can see from this angle. Wow, what the heck? How is that possible? So let's try and put it for 10. Okay, so there's a 10 volt readout here. And then we should go down here, and this says, oh, it also affected. No, it did not. 9.75. And then I put it for 10 on the meter. Oh, that was a little bit of a unstable. So, I mean, this is still really, really good. And 5 is there. What the heck? How can this meter be so accurate? And this should be 2. All right, this is good enough for most things. So here should be 6. All right, and current is super smooth and all that. Now I just want to load it and test some ripple and all that. Let's try something real funny. So we put the amp meter in 1 amp here. So my load is 900 milliamps, so this is real close to maximum, and I cranked up the current to full. Voltage is about halfway up. And let's look at a little bit on the outside output voltage here in AC mode. So this is a real good way to look at the quality of a power supply. So here, see? So this is the load. The voltage drop when I apply the load, and let's look at the load drop when I release the load, and then the voltage overshoots like that. This is really not bad. We got 100 millivolts per division. This is not bad at all. I'm quite impressed. I mean, it's 5 little germanium transistors and 2 output power transistors. That's all there is into this one. And it's actually really, really good. We should maybe look a little bit more at the internal parts here. So we've got all those power resistors loading the center point between those 2 transistors. We've got some other load resistors here. And that's of course the controller board. Yeah, since I found the schematic, I've been redrawing it and updating it a little bit so I can show the schematic, but I just wanted you to see all the details first so it makes a lot more sense. That will be the current sense resistors, and what we got right here, we got the inductor and the main charge capacitors. That's of course the rectifier bridge. In the schematic they just call this 4 diodes, but it's of course a bridge. And the voltage selector, current selector, switches like that. There's just one little, I would maybe call it a dumb thing. That is, if you think a little bit about it, those switches, they're actually a double switch. What you see here is the bottom side of all 4 switches. The other side, the top side, is what they used for the soldering all the wires. And the top side is where all the dust collects directly into the switches. And everything here was super, super dirty. When I opened them, I had to clean this before I could show you guys because we couldn't see anything. And it was so bad and smelly, I really needed to go outside with this immediately. But you can probably imagine all the dust goes directly down here to the switches here. Well, what I really find a little bit dumb and silly, why don't we parallel at least the switches, the top and the bottom part of the switches, because they're in parallel of each of those. That will give us the double, the double safety, or the the double quality of each switch feature. Yeah, I had to clean everything here. The old lubrication turned into goo, and I added a lot more like nice new lubrication, and this is why those switches here, they go really nice and fine and smooth. Here is the schematic of the A50 version with PNP transistors. I think it is a very, very funny schematic to yeah, to put it that way. And the reason why they have done it this complex. So let's look in the left part first. We got two transistors and they appear to be in series to our output. That is just because the transistors they could get in this size and power didn't really handle all the voltage they had available, and they wanted to have a lot of extra voltage to regulate from. So that is why they have the two transistors in series actually, and we also have two heat sinks in there that's isolated and all that. So the little signal transistor in the top left corner is the one that handles actually driving both of those transistors, but with a different voltage drop over them. That is really, really cool. I also like the 4 switches for the 4 different meter readouts. It's drawn in a very nice and easy to understand way. If we start to see, they actually made a little picture of the 4 buttons you push in, and you can see now you have pushed in 32 volts range, and that way it's easy to understand how the meter is now connected to the output voltage via a 31K6 resistor. And they're using 0.5% resistors. That's also a little bit amazing. And it really does measure really, really accurate. And of course, if you flip it to current mode, you will see now it's the 2 switches to the left. We'll then see the meter is directly connected across 2 resistors that they are made like springs mounted on the back of the meter. In the upper right corner we see again 2 AC 128s, and that is a differential amplifier where you compare the output voltage and then handle the voltage feedback system. The transistor to the left of the differential amplifier there is the one that is handling the current limiting. So this, when this transistor gets a drive signal, it kind of kills more and more the voltage feedback, and this way you have a current feedback system. I also like the 2 Zener diodes in the middle. That is because of the 2 reference voltages. It's running at 6.8 volts and 12 volt over and under the negative side of the output, and that's why you see 3 rectifier bridges in this power supply. Today you could do this with 2 and 1 little op amp, of course, but they didn't really have op amps when they did this design. And this is the A51, the one with NPN transistors. And now I know why voltage and current is flipped. Of course, it's because of the all NPN transistor. The whole system with regulation and how you feedback the voltage and all that, everything is completely flipped. And that is why this potentiometer here, see, voltage potentiometer is now moved to the negative side instead of the positive side. Because they just wanted this line here to go directly from negative to the potentiometer, and then this little capacitor, and then to the circuit board. I mean, That is really why. Amazing. By the way, this one is also really, really bad with both potentiometers. They're full of dodgy connections. So I'm just gonna do exactly the same. Open both potentiometers, clean, and assemble again. And then I think this one is done. So now I'm done with the potentiometers in the other one. I think I forgot to show how bad the switches they actually started. See? Now it comes out completely gunked out. They don't really move that well because of old, nasty, dried lubrication and dust all over the place. I think I want to call it a big success. Both of them are now working and they perform really, really good, accurate, and regulation and ripple and everything is just perfectly fine. It's a little bit amazing with just a few transistors and what you can do, to be honest. You don't need all those sexy op amps and whatnot. Well, that is how you made a power supply in 1960 to 70 something. Thank you very much for watching. Hope to see you soon again. Bye.